Hey, today we are doing lesson 2-1 and we are going to start talking about rational numbers. So we're going to use those rational numbers just like we did integers. We'll be talking about the absolute values of them, finding the opposites of them, graphing them on number lines, talking about when we would use them in real life. So today's Spark Your Learning talks about the magnitude of a star, and that is the number that is a measure of its brightness as seen on Earth. So the brighter the star, the lower the magnitude. So the data below is going to show us magnitudes of these 5 stars here that we can see in our galaxy. And we're going to decide between what two integers, remember integers are the whole numbers, is the magnitude of each star. So in most applications, when we're talking about magnitude, it's going to be an amount or a size. However, stars have magnitudes as well, and that includes negative numbers for stars. So we can see here, we've got all of these rational numbers here, and we need to decide where on the number line, what whole numbers, the integers, would they go between. So you're going to think about where on a number line would you put 1.97, between what whole numbers is that going to go. So here you can draw yourself a little number line. You can explain how you figured out each one, and then there's some drag and drops to check your work with. So if you want to pause the video and do your Spark and then come back and see how I solved it. So the way I think about these is I know I'm going to need a number line, and I'm going to put 0 on there since I have negative and positive numbers. So I'm going to start with and get a few integers on there. So 1, 2, I'm going to get some negative ones on my number line here, and then we'll see if I need any more. So I know Polaris, our North Star, is 1.97. So I know that is going to be toward the positive side. And if I round this up, I know that 9 will make the 1 turn into a 2. So it's almost a 2, but it starts with a 1. So it's going to be almost to the 2. So right here is 1.97. Now my next one is a negative. So I know I need to go toward the negative side. I know it starts with a 1, so I need to find the 1 area. And that means it's almost 1.5, 1.4. So I know it's going to be in between 1 and 2. So here is negative. It does not want to make that 1. There we go. Negative 1.45. So next we have 0.6. So I can see that it does not have a whole number. So it's going to be somewhere by 0. But I notice it's on the positive side. So it needs to go toward the 1. So it's going to be somewhere between the 0 to 1 category, just a little past the halfway mark, 0.61. Next, we have Arcturus is negative. So I know I need to go to the negative side. I see it starts with 0, and then there's another 0.4. When I use decimals, the easiest way for me to think about decimals is to think about money. And so I know that's 4 cents, like negative 4 cents. So it's going to be really close to that 0 right there, negative 0.04. And then our last one, Canopus, is a negative, and I can see less than this one here, the Arcturus, and 72 cents is closer to $1, but I know it's on the negative side, so negative 0.72. So I had a lot of different ways that I had to think about those. This one, I used rounding to kind of think that's almost to 2. I used comparing to a half on this one, thinking, oh, 45 cents is almost like a half. I also used money knowledge to help me place things and think about that's 4 cents, this is 72 cents, and where those will go. So I use a lot of different strategies to help myself determine where those would be. So on here, we're talking about the magnitude and what consecutive integers it goes between. So I said 1.97 was between the integers of 1 and 2. So down here, I'm going to look for 1 and 2, drop those there. So now I'm looking for -1 and 45 hundredths, which I said was between -2 and -1. So each time I'm looking back at my number line to help me. So 0.61 was between 0 and 1. So 0 and 1. And then my last two were both between -1 and 0, -1 and 0 there. Okay, so now I want you to think about how many decimals are between the numbers of 0 and -1. So I want you to answer that and pause the video and then come back and listen to what I have to say. So decimals, they can just keep on going. So I could start with the decimal of just 0.1, but I could add on to that and I could make it into the hundredths place. Now there's all of these. This is like 0.1, 0.2, 0.3. Then I have all of these here, 0.12, 0.13, and these are all going to keep on going. I could keep on adding. I could do 1,111 in there. Each time I could make it to the tenths. I could make my decimals to the hundredths, to the thousands. And just like our whole numbers, they keep on going forever to infinity. My decimal numbers can keep on going. I can just keep adding decimal places to the right and making my decimals even smaller and smaller. So really, there's an infinite amount of decimals between the numbers 0 to 1. So just in that little tiny place, 0 to 1, we have an infinite amount of numbers, and then we would keep on, and I just realized this is -1. So I would just turn all of these negative, but the same concept still applies. We're going to add in those decimal places to the right and keep getting smaller and smaller. So an infinite amount in between every single whole number. Okay, so make sure you go and tell me what strategy or what you learned back in the Spark on Canvas, and then come back and do the tasks with me. So our first thing we're going to do here is we're going to take a look at some vocabulary words. So a rational number is a number that can be written in a fraction. So it's a number that can be written in a fraction form. You have a numerator and a denominator. A and B are integers, so whole numbers, and they're opposites. And B, the denominator on the bottom, cannot equal 0. So here's some examples of rational numbers. 0.35. So you might be wondering, well, I just said it has to be a fraction. Well, any fraction we can turn into, any decimal we can turn into a fraction. 35, here's the hundredths place, out of 100. 35 is an integer, 100's an integer, 35 hundredths. So anytime you have fractions, those are rational numbers. Anytime you have a decimal that ends nicely, that is a rational number. So here's a fraction, 4/5, integer, integer, 4 and 5 are integers. The number 6 is an integer. So and it's also a rational number. 6 is a whole number, but I can put it over 1 and make it a fraction. So all of the whole numbers are also rational numbers. And one more example, you can also have whole numbers mixed with fractions and decimals to create a rational number. So essentially, most numbers are rational numbers. Fractions and decimals that end nicely are positive and negative are all rational numbers. So just to review here, I want you to stop and think and pause this video and see if you can think of what each place is called before I move them there. So I know right to the left of the decimals is the ones place, and 10 times bigger than that is the tens place. Into the decimals, the first place I get is the tenths place. THS on the end tells me I have a decimal place. And every time we go to the right, we're getting 10 times smaller. So if I break up a 1 into 10 pieces, we have tenths. If I break up a tenth into 10 pieces, that makes a block of 100. So the hundredths place, these are like dimes, these are like pennies. And then we also have the thousandths place. After that, we don't use the decimal places a lot, but just know there are decimal places that can continue on forever, just like whole numbers. So these number lines can help us think about rational numbers. So we're talking about tenths for the most part and hundredths. So I can see from here to here is one whole thing, and going the other way is one negative unit. And then inside of each of these, it's broken up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So each of these is a tenth. If you look up here, you can see that a little bit bigger. So here's 1 tenth, 2 tenths, 3 tenths, 4 tenths, all the way over. And when we get 10 tenths, that means we have one whole unit there. So as you're doing some of your work today, think about these number lines, and that in between each whole number, there's also a set of fractions in there. So let's go to our first task here. So it tells us that the average low temperature in Nome, Alaska in January is the rational number negative 2.8 degrees Fahrenheit. So it's below zero on average, negative 2.8 degrees. A consecutive mark, so that means in order on a number line, increase and decrease by the same amount. So when we make number lines, we can't all of a sudden be counting by twos and then start counting by fives and be like, oh, I'm going to count by hundreds instead. You always need to count by the same thing. If you start counting by ones for all your units should be labeled with ones. If you do twos, decimals are the same thing. So what marks would we need to make to graph negative 2.8 on a number line? So the easiest way to think about this is to think about where is that decimal place, that 8. If you can't remember, you can rewind the video just a little bit and go look at that number line and the labels that we put on there. And so this 8 is in the tenths place. So you would need everything to count by tenths to be able to mark exactly 2.8 on a number line. You could count by something bigger, but you wouldn't need to mark negative 2.8. So now it wants to know between what two consecutive integers is 2.8 located between a number line. So we are going to pull this back up and we're going to think of negative 2.8. So I can see negative 2.5, 2.6, 2.7, 2.8 is right here. So then I'm looking for the whole numbers. So I can see that negative 2.8 is between 2 and 3. And I can do that without the number line as well. If I have, whoops, I did not mean to put that there. So negative 2.8. I just need to start that over. Let me rewrite that. Negative 2.8. I know it has to be between 2, and then the next biggest number is 3. It's actually smaller. So between 2 and 3. So if I come back here, I know it's not between positive. I've got to get that negative on there, negative 2.3. So if I was wanting to graph negative 2.8 on a number line, I would plot a point blank tenths to the blank of 2. So let's come back to our number line again. So blank tenths to the blank of 2. Well, I know I need to go to the left, starting at 2, 1, 2, 3, 4, 5, 6, 7, 8 tenths to the left of 2. So if you need to draw yourself a number line, please do that, okay? Or you can even search for number lines with tenths on them and print them out if you need to. So next we're going to complete the statement to describe the position of negative 2.8 compared to 0. So let's come back and look at our 0 here. So here's 0. I know negative 2.8 is still to the left because it's negative. And I have to go 2.8. So 2 whole units and 8 tenths more. So let's take a look at what our task says. So the number 2.8 is 2.8 units to the left of 0. Okay, so 2.8, a distance of 2.8 to the left. The opposite of 2.8 is going to be completely on the other side of 0. So 2.8 on the other side of 0 makes that 2.8 if I go in the opposite direction from 0. So the opposite of negative 2.8 will be 2.8 units to the right of 0. So the opposite of negative 2.8 is positive 2.8. So now we're going to graph each of these. Remember that negatives go to the left and positives go to the right. Okay, task 2 here today has this swing set here, and it tells us that the legs are buried half of a foot in the ground or 6 inches down into the ground. So we can see that here. What marks on a number line would we need to graph a half? So if we were just going every half of a foot, we would want to use that denominator here, the half, to mark up our number line. So now we're going to look at a half on a number line. And I know this doesn't have fractions on it, but I know that 50 cents is half of a dollar, 0.5 is the same thing as 1/2. So if I'm over here at 0.5, I know that's going to be the same thing as 1/2. So let's look at what our question asks us. So 1/2 is between which integers? Let's look at that first. So I know 1/2 is between 0 and 1. We do not have a whole number, and it's to the positive side. So then the other part of so it's between 0 and 1. 1/2 is blank to the blank of 0. So it's a half of a unit. So we're only going halfway to the positive side right of 0. Which statement describes the opposite of a half? So looking back at that number line, going to the other side of 0 would put it as negative 0.5 or negative 1/2. So remember, opposites are same distance, opposite sides of 0. So I know the opposite of 1/2 is negative 1/2. So I know the opposite. So the opposite of 1/2 will be 1/2 units. We want to get negative. So we need to go to the left of 0. So we're going to go to the left of 0, 1/2 units. So Read through and see which one tells us to go 1/2 to the left of 0. Okay, and then you're going to drop 1/2 and negative 1/2 on the number line. Negatives go to the left, positives to the right. Okay, and I want you to think about what marks you would put on a number line to graph negative 0.375. And there's more than one answer here. So take a second and pause and do that and come back and hear some of my thoughts about it. So one way you could do that is I can see this 5 is in the hundredths place here. So you could every hundredth, and you could between 0 and 1 on both sides of the number line have 100 places, and then 100 more places between 1 and 2, and 100 more places between 2 and 3. That's a lot of marks. I know that 75 is divisible by 25 quarters, 25, 50, 75, a whole. And so I would make quarter marks. I would start at 0 and then do 0.25, 0.5, 0.75, a whole. And then keep going, and that's on the negative and positive side, 1.25, 1.5, all the way out. So if I were doing that, because sometimes I'm lazy and I don't want to make 100 marks in between each one, I would find a smaller number, well, it's a bigger number, to make fewer marks. So I would use quarters or fourths in order to break up my whole numbers. There's a lot of ways that you could do that same problem. Okay, moving on. This is our last task today. So in a previous lesson last week, we figured out how to solve for absolute values of integers. Those whole numbers, remember it's the distance to 0, it's positive. We can find rational numbers the exact same way. You just tell the distance to get to 0. So we have an elevation at Death Valley that is negative 0.5 miles. So it is below sea level. So the distance from 0.05 to sea level, so it would take me 5 hundredths to get back to 0. And we need to remember those are always going to be positive. Distance is a positive number always. So we just take this same number, make it positive. Okay, B asks, between which two consecutive integers is negative 0.05 located on a number line? So I know the number 0.05 is like 5 cents. I always like to think about decimals as money, and we're talking about a negative, so I have lost 5 cents. I do not have that. So I know this decimal up here, 0.10 is like 10 cents, negative 10 cents. 5 cents is half of 10, so negative 0.05 would be here. So the integer closest to it is 0 because it does not have a whole number. And the next whole number it would go to is negative 1. So negative 5 hundredths is between 0 and negative 1. So between negative 1 and 0. Okay, and we are going to complete this number sentence, and notice that these lines here are asking for the absolute value. So what is the distance from 0.05? How many hundredths would you have to count back to get to 0? And remember, absolute values will always be positive. So that is everything. Oh, there is one more task. That's not everything. So there's one more task. So Mrs. Sutter withdraws money from the bank. So withdraw means taking away. And the transactions are recorded on her bank statement. So we're going to find out how much money she actually got. So to her bank account, it does look like a negative amount, but then she now has that positive amount. So if she took out $5.25 from her bank account, she now has $5.25 in her pocket. So go ahead and see if you can tell me what those absolute values are of her withdrawal amounts. $3.50. So I know seven's going to be over here somewhere, $7.10 that she took out. She also took out negative $3.50. So looking here, I know that negative 350 is farther to the right. So that's a greater amount. So we want to come back here and answer these questions. So the number negative $3.50 is greater than negative $7.10 because it's located farther to the right. Remember, right is always bigger on the number line. When she withdraws $7.10, it makes a bigger decrease in her checking account. So the more money you take out, the less money you have in your checking account. So 350 is greater, but the 710 actually made a bigger dent in her checking account. Okay, so now that's really everything. And so make sure you click I'm done on your tasks in Spark and then do your check for understanding. You also have some practice to do today as well.